Hello everyone. In fluid statics, we will discuss about simple situations in which the fluid is at rest and interacting with the solid boundaries. So fluid statics can be defined as the study of fluids at rest and how does they interact with the solid boundaries. On the same lines of solid mechanics, we are considering fluid statics first. The reason is many fluid problems do not involve motion. The design of many engineering systems such as water dams, liquid storage tanks, hydraulic presses and many more requires the determination of the forces acting on the surfaces. You can see here a dam wall and a fluid at rest is present here. So this fluid at rest, it exerts some force onto this dam wall and this force have to be calculated. Similarly, in a liquid storage tank, in hydraulic presses, liquids at rest we have, and these liquids as they interact with the solid boundaries exert some force onto it, and these forces has to be determined. The determination of the forces exerted by a fluid at rest on the solid boundaries is done with the use of principles of fluid statics. And under the domain of fluid statics, we are going to learn about how does a pressure vary in a static fluid. We are also going to learn about forces on submerged planes, and a very important we'll be learning is concept of buoyancy and stability. Now first we'll talk about pressure variation in a static fluid. Before that, we should understand what is the meaning of the term pressure. So to do that, let's consider a large expanse of a fluid at rest we have, and one small fluid element we are considering within this large expanse, and this fluid element, it is taken in isolation. So the fluid element we have taken it outside, so this fluid element is isolated now from this fluid system, and now we can determine what forces acts onto it, and once we understand forces acting onto it, we can draw a free body diagram. So on this fluid element, basically two types of forces can act. First one is a body force and second one is a surface force. Now what is the meaning of the term body force? So body forces are those which acts throughout the mass of the system. So here we have a fluid at rest, and throughout the mass of this fluid, the gravity forces are acting. So gravity force can be considered as a body force. Similarly, if we put this fluid element in a magnetic field, the magnetic forces will act throughout the mass of this body or throughout the mass of this element, and it can also be considered as a body force. But when we are talking about the situations that is fluid at rest, we are considering only gravity forces, and hence on this element the body force which is acting, it is a gravitational force which is acting in the vertically downward direction. Now in addition to this, one more force is acting which is known as surface force. This fluid element, it is surrounded by a large number of fluid particles which exert force onto the surfaces, and this force which is exerted by a large number of fluid particles on the surfaces of the element are known as surface forces. Now these forces can act in two different ways. If we consider this inclined plane surface, onto this the force exerted by the fluid particles surrounding to this element can be in tangential nature or it can be in normal nature. So tangentially the forces can act, or perpendicular to the plane it can act, and these forces are known as surface forces. But now as we know, the fluid, it is at rest, there is no motion present, and the velocity is equal to 0, and we can say that the shear force component will be 0. So we will not consider the shear force component, we will have only normal force component, and this normal force is acting on this inclined plane area. We defined, or we know one term which is known as stress, which is defined as force per unit area. Similarly, we can define normal stress as normal force per unit area. So here the normal force is acting onto this area, and which is known as normal stress. But this normal stress, in case of fluids, it is known as pressure. So pressure and normal stress, they are synonymous terms, but normal stress we are using when we talk about solids, and when we talk about liquids or gases, we call it as a pressure. Now as we understood what is the meaning of the term pressure is, we should understand how does the pressure varies in a static fluid. So if we consider a large expanse of a fluid which is at rest, the pressure can vary with direction at a point, or it can vary horizontally as well as vertically. So let us consider a point here, and at this point the pressure will be acting from different directions. So this pressure which is acting from different directions can be different, or it can be same. Similarly, along a horizontal plane also the pressure may vary, as well as in the vertical plane also the pressure is going to get varied. So this have to be determined. How does a pressure vary at a point with respect to directions, then along a horizontal plane and along a vertical plane? So to do that, we'll take one small fluid element in a large fluid system which is at rest, and we'll take this fluid element in isolation. We'll take it outside, and now we'll draw a free body diagram for this element. So the element is taken outside, and now we'll define this element with the use of a Cartesian coordinate system. So in this direction we have x coordinate, in the vertical direction we have y, and in the third direction we have z coordinate. And now accordingly we'll define lengths of this element. So this length in the x direction is delta x, this height or length in the y direction is delta y, and this length in the z direction is delta z. This arbitrary inclined plane surface we have, and the length of this inclined plane surface, it is defined as delta s. So let us consider this length is delta s. Now we are going to identify the forces acting onto this element. So we know there are two types of forces, surface force as well as body force. Now first we will go through the surface forces, and we know surface forces are the resultant of the force exerted by the surrounding fluid particles, and we understood that the forces are only normal forces we are considering. So now if this left plane we consider, so on this left plane perpendicular to it some force will act. Similarly, on the bottom plane perpendicular to it some force is going to get acted in the y direction, and this plane, it's arbitrary plane. So perpendicular to it, it means that it's not along x, y or z, it's in the arbitrary direction. So we'll denote this direction as n direction. So perpendicular to this plane also the force is going to act. We can resolve this force in horizontal as well as vertical component later on, and just we have understood that the forces acting on the plane surfaces perpendicular to it we have identified in the x direction, y direction and in n direction. Now what is the amount of this force? We understood pressure. Pressure is force per unit area. Therefore force is pressure into area. So let's consider pressure acting in the x direction. In x direction pressure acting is Px multiplied by area. How much is the area? This plane area is delta y multiplied by delta z. Accordingly, Px into delta y delta z is the force acting onto this left plane. Similarly, on the bottom plane we can identify the force which is acting. So the direction is y direction. So the pressure, let us consider, acting in the y direction is Py, and it is acting onto the area delta z multiplied by delta x. So Py into delta x delta z, it is nothing but pressure force which is acting in the vertically y direction. And now this third direction we can take, which is n direction. So pressure acting in the n direction is Pn, and the area onto which this acts is delta z multiplied by delta s. So Pn into delta s into delta z is the normal force which is acting onto this plane surface. Now this angle will consider as theta. So let's assume this angle is theta. So from trigonometry it is clear that this angle will also be a theta. So this vertical component will be a cos component, and this horizontal component will be a sine component of force. So now one more force will act, which is known as a body force, and we understood that only gravity forces we are considering. So throughout the through the center of mass of this element, the gravity force will act in the vertically downward direction, which is nothing but a weight of this fluid element, and weight is given by mg. So this is the body force which is acting. Now this element, it is in a state of equilibrium because the fluid, it is at rest. So as it is in a state of equilibrium, we can apply the equilibrium conditions. So one by one we'll consider x direction and y direction, and we'll apply the equilibrium conditions in x and y. So considering x direction first and applying the first equilibrium condition, that is summation of forces in the x direction equals to 0. So in the x direction, what forces are acting? So this px into delta y delta z, it's acting in the x direction. So let's consider rightward are positive and leftward forces are negative. So it is acting in the rightward direction, so it's a positive component of x direction force. This is a sine component of this normal force. So Pn into delta is delta z multiplied by sine theta. So it will give you the x direction component, and it is acting in the leftward direction, and hence it's a negative component. So writing this into the equation, so Px into delta y delta z positive minus, plus minus of this Pn into delta s delta z sine theta, and it is equal to 0. Now we'll solve this. So to solve that, we'll now write equation for this sine theta from trigonometry. So sine theta is equal to how much? It's opposite upon hypotenuse. Opposite is delta y, then opposite is delta y, and hypotenuse is delta s. So delta y upon delta s, and hence sine theta we can write here it as delta y upon delta s. So if you put delta y upon delta s here, delta s will get cancelled, and this plus positive and negative, it will result in a negative sign, and hence equation you will get is px into delta y delta z minus pn into delta s. Instead of this delta s, you will have delta y delta z equals to 0. And after solving this, shifting this second term towards RHS, you will get px into delta y delta z equals to pn into delta y delta z. So these two terms will get cancelled out, and at the end you will get px equals to pn. Now similarly, we'll apply the equilibrium condition in y direction. So equilibrium condition in y direction is summation of forces in the y direction equals to 0. Now we'll identify the forces acting in the y direction. So the forces acting in the y direction are, so first one is this body force, which is acting in the vertically downward direction. So we'll consider downward negative and upward positive. So it is minus mg. This py into delta z, it is acting in the vertically upward direction, so it is positive. And this component of the normal force, it is a cos component, which is acting in the vertically downward direction, so it will be a negative component. So writing in the equation form, that is py into delta x delta z, it is positive, plus minus of pn into delta s delta z cos theta. So it is nothing but pn delta s delta z sin theta component is this vertical acting in the downward direction, so that's why it is negative, and plus mg. So mg, it is vertically downward, that's why it is with a negative sign. So plus minus mg equals to 0. Now solving this, what we will get is py delta x delta z plus minus of pn delta s delta z cos theta, will keep it as it is. And now we'll identify what is the equation of this mg, that is weight. So as we know, density is mass upon volume, therefore mass is equal to density into volume. So I can write it as minus rho v into g. So minus rho vg is nothing but what? Density into volume multiplied by acceleration due to gravity. So v is the volume of this element, and what is the volume of this element? It's the area multiplied by length. So how much is the area of this triangle? Half base into height, that is 1 by 2 multiplied by delta x delta y. So 1 by 2 multiplied by delta x delta y into the third direction length is delta z, so into delta z. So this term is nothing but volume. So minus rho g half delta x delta y delta z is the weight mg, and now we are putting this here into the equation, which is equal to 0. Now we will solve this equation, and after solving, what we will get is the same kind of equation, that is py equals to pn, and so cos theta equals to delta x upon delta s. So cos theta is what? Adjacent upon hypotenuse, so adjacent is delta x, hypotenuse is delta s. So put this delta x delta s here into the equation. So after putting this and solving this, what we will get is py equals to pn. Now we understand that previously we got px equals to pn, py equals to pn. So from this we can write px equals to py equals to pn. It is known as Pascal's law. And what does it states? It states that at a point, the pressure acting on to the point is the same from all the directions, and it is known as Pascal's